Hello all, welcome to my YouTube channel. Today we shall understand principle of least square. Okay, in my earlier videos I have already explained scatter plot, regression line, and with the help of an example I have shown you if a data is given of two variables x and y, how to find out the line of regression. Okay, so today we shall understand the principle of least square to find the line of best fit. As the name defines, the line of best fit means the line which fits the data in best possible way. Okay, so we shall understand the principle of least square. What is this? It is the minimizing sum of squares of errors of difference between the actual value and the estimated value of y as given by the line of best fit. Let me explain you in details. Suppose we are given 5 data points, okay, and we have plotted a scatter plot on them, okay. So these are 5 data points, okay, and I draw a straight line through them. Now this straight line is given by y hat equal to a plus bx. This is the line of regression. Okay, so when will be this line of regression the line of best fit? Okay, let me explain you. Suppose this is one data point, okay, and this is the actual value. Suppose the value is given by x1, y1, okay, and from this regression line the estimated value of this will be this one, x1 y1 hat. Okay, how we get this y1 hat? We plot the value of x1 in the line of regression a plus bx. So a plus bx1 gives our y1 hat, the estimated value of y. Okay, so this is given by this point x1 y1. Now if we draw a perpendicular from the actual value to the x-axis, okay, the distance between the actual value and the estimated value is called the error of estimate. For this one, this is E1. Okay, so what is E1? The difference between the actual value of y and the estimated value of y, y1 minus y1 hat. So it can also be written as y1 minus a plus bx1, okay, since y1 hat is a plus bx1. Now for all other points, if we draw the perpendicular and we find out the distance from the actual value to the estimated value, okay, so in general they are given by EI equal to YI minus YI hat or YI minus A plus BXI. Okay. Now what is the principle of least square? If we square all the EIs and sum them, that is called sum of squares of errors, okay, and we have, it is also can be written as summation yi minus a minus bxi whole thing square. We have to minimize this summation ei square to get the line of best fit. Okay, so we find out the values of a and b in such a way that summation ei square is minimum. Okay, so that is called principle of least square. Suppose E equal to summation ei square, okay, so by the principle of maxima and minima, we have to differentiate E with respect to A and put equal to 0 and differentiate E with respect to B and put equal to 0. Okay, so let's see what happens if we differentiate VE with respect to A. So when we are differentiating with respect to A, so this is the function of A. Okay, so first what we do, square term, so becomes 2 summation yi minus A minus bxi, and then we differentiate with respect this one with respect to A. Okay, so this becomes minus A differentiated with respect to A becomes minus 1. Put equal to 0, which gives us minus 2 summation yi minus A minus bxi equal to 0. Okay. Now minus 2 is, if we send it to right hand side, then we get summation yi minus A minus bxi equal to 0. Okay, so which if we break the bracket, remove the bracket, what we get, summation yi minus A and A minus b summation xi equal to 0. So finally we get summation yi, and we put everything else to the right hand side. So na plus b summation xy. This is equation number 1. Now we differentiating with respect to b. So what we get, first square term, so 2 summation yi minus A minus bxi equal, then we differentiate this bxi with respect to b. So what we are left with, minus xi because here xi is the coefficient of b, put equal to 0. So what we get, minus 2 summation xi multiplied by yi minus A minus bxi equal to 0. Sending minus 2 to the right hand side and then removing the bracket, we get summation xi yi minus A summation xi minus b summation xi square equal to 0. Xi multiplied by xi, so we get xi square. Keeping summation xi yi to the left hand side and sending others to the right hand side, we get summation xi yi equal to A summation xi plus b summation xi square. This is equation number 2. So these two equations are called normal equations for estimating A and B. So the normal equations for estimating A and B are given by these two equations, summation yi equal to na plus b summation xi, summation xi yi equal to A plus A summation xi plus b summation xi square. A is the y-intercept and b is the slope. From the given data points, we can find out summation yi, summation xi, summation xi yi, summation xi square, and then put the values in these two equations, and then we can solve for A and B. Okay, so we can, this is normal equation. Now we shall go a little bit further to find out the another formula for estimating A and B, which I have used in the line of regression in my earlier video. Now what we do, see equation number 1, if we divide both sides by n, so what we get, 1 by n summation yi, n A by n, so we are left with A plus b into summation xi by n. Okay. So, what is 1 by n summation xi? Summation yi, sorry, this is y bar. Then a plus b into summation xi by n is x bar. Okay. This can further be written as a equal to y bar minus bx bar. So, this is the formula for to find out a, the y intercept. Okay. So, which is given by a equal to y bar minus bx bar. Okay. So, if we want to find out a, we have to find out b first. Let us see how to find out b. Now, for our record, we mark this as equation 3. Y bar equal to a plus bx bar is equation 3. We shall use this equation, okay, later. Also, this equation 3 tells us that the line of regression passes through the point x bar y bar. Okay, so this is a very important equation. Now, covariance between x and y is given by covariance of xi. There are various notations for this. We shall use this one as xy. Okay, and what is the formula for this? 1 by n summation xi yi minus x bar y bar. What we shall do is that we shall bring this summation xi yi to the left hand side, and the right hand side becomes sxy plus x bar y bar. Okay, and also the variance formula, variance of x, it is given by the notation sxx or sx square. Okay, we shall use sxx, and what is the formula for this? 1 by n summation xi square minus x bar square. This can also be written as 1 by n summation xi square equal to sxx plus x bar square. Okay. Let us mark these two equations as equation 4 and equation 5. Now you remember the second normal equation, summation xi yi equal to a into summation xi plus b into summation xi square. What we do? We divide by n. Both sides we divide by n. So, what we get? 1 by n summation xi yi equal to a into summation xi by n. We know that this is a x bar, and b into 1 by n summation xi square. Okay. Now we shall use equation 4 and equation 5 in this equation. Okay. So, what we get from equation 4? This equal to sxy plus x bar y bar is equal to ax bar plus b into sxx plus x bar square. This we have put from equation 5. Now you remember equation 3, y bar equal to a plus bx bar. What we do? In equation 3, we multiply both sides with x bar. So, what we get in the left side, x bar y bar is equal to a x bar plus b x bar square. Now, what we do? Subtract this equation from this equation. Okay. So, suppose this equation is equation number 6, and this equation is equation number 7. Okay. So, subtracting 6 from 7 gives us, okay, in the C in the left hand side. Left hand side is sxy plus x bar y bar minus x bar y bar. So this x bar y bar gets cancelled. So in the left hand side we are left with sxy, and in the right hand side ax bar gets cancelled. Okay, and also bx bar square gets cancelled. Okay, so in the right hand side we are left with b into ssxx. This gives us b equal to sxy by sxx. b equal to sxy by sxx, which can further be written as sxy is, we know that this is covariance of xi, so which is equal to 1 by n summation xi yi minus x bar y bar divided by 1 by n summation xi square minus x bar square. Okay, this can be further simplified as 1 by n summation xi yi. X bar y bar can be written as 1 by n summation xi multiplied by 1 by n summation yi. Okay, and in the denominator 1 by n summation xi square minus 1 by n summation xi whole thing square. This gives us, further simplifying, this gives us n into summation xi yi minus summation xi into summation yi n into summation xi square minus summation xi whole thing square. Okay, so this formula we can use to find out the value of b. Okay, from the given data we can find out summation xi yi, summation xi, summation yi, summation xi square. Okay, summation xi, and then we can find out the value of b. So after we find out the value of b, we can put the value of b and in the equation y bar minus bx bar to find out the value of a. So this is b equal to the slope, value of slope, and this is the value of y intercept. Okay, so if we find out the a and b, this line of regression, and put in the line of regression y hat equal to a plus bx, this gives us the line of best fit. Okay, hope you understand my teaching. If you like my video, please like and subscribe. Thank you for watching.